Okay, now we're on number 2. We're given this integral to evaluate. This is one of those improper integrals. We can spot that immediately because we have an infinite limit there. So the first thing you do with improper integrals is to rewrite them as the appropriate limit. So what do we mean by the integral from 0 to infinity? Well, we mean that it's the limit as b goes to infinity of the integral from 1 to b x over x squared plus 1 squared dx, provided this limit exists. So what we need to do is go off and find the antiderivative of x over x squared plus 1 quantity squared. So I can rewrite that. Bring the denominator up to the top with a negative exponent. And then I think back to chapter 6. I'll let u be the thing in parentheses. My du is 2x dx. I have an x. I can snuggle over there with the dx. But if I want to get a 2x dx like I need, I'll need to offset the entire integral by a half. So I get that. So in the land of u's, this becomes 1/2 integral u to the minus 2 du. I apply the power rule. 1/2 u to the minus 1 over minus 1 plus a c, which is minus 1/2 u to the minus 1 plus c. We've solved it for you, now you got to solve it for me. I want the x's back in there. So I get minus 1/2 x squared plus 1 to the minus 1 plus c. This is now my antiderivative. So the limit as b goes to infinity of the integral from 1 to b x over x squared plus 1 squared dx is the limit as b goes to infinity of minus x squared plus 1 to the minus 1 over 2 evaluated from x equals 1 to x equals b. This is the limit as b goes to infinity of, substitute the b in there, minus b squared plus 1 to the minus 1 over 2 minus what you get when you substitute the 1 in. I'll have minus a negative, that'll be a positive 1 squared plus 1 to the minus 1 over 2. So limit as b goes to infinity. 1 plus 1 is 2. 2 to the minus 1 is going to shift the 2 down here. So I'm going to have a 1 over 4. This remains a minus. And to see the forest for the trees, I'll put him back in the denominator. So as b races off towards infinity, I'm thinking of plugging in very large positive numbers. For example, b equals a billion, a trillion, etc. If I plug in very, very large positive numbers, this becomes a very large positive number. 1 divided by a very large positive number is a very small positive number. The bigger the b gets, the smaller this gets. So this term is going to 0. The only thing that survives is the 1/4. And so we would say that the integral from 1 to infinity, x over x squared plus 1 dx, we would say that this integral converges, and it converges to the value 1/4. And that'll do it for number 2.